In this video, we are going to be talking about the statistical test in nursing research. This consists of Taylor, Whitney, and Brittany. We are going to be talking about descriptive and inferential statistics, non-parametric and parametric, measures of central attendance, chi-square, Pearson's correlation, t-test, ANOVA, and lastly, regression. In this, we will be talking about why they're used, when can it be used, what criteria needs to be met, giving an example, and then what they actually are.
First, I will describe descriptive statistics. Descriptive statistics are summary statistics that allow the researcher to organize data in ways that give meaning and facilitate insight. Descriptive statistics are calculated to describe the sample and key study variables. And inferential statistics are designed to address objectives, questions, and hypotheses in studies to allow inference from the study sample to the target population. Inferential analyses are conducted to identify relationships, examine predictions, and determine group differences in studies. Descriptive statistics and inferential statistics are data analysis processes which are included in quantitative research studies and involve the management of numerical data and the statistical analysis of that data to produce study results.
I will now be talking about the analysis techniques which are identified as parametric or non-parametric statistics. Non-parametric statistics are measured in nominal and ordinal levels. The data does not need assumptions, and they are conducted when data is not normally distributed. On the other hand, parametric statistics are measurements of variables in interval or ratio levels. Data can be treated as though it was a random sample, and the sample draws from a population that is distributed of scores which is expected to be normal. And lastly, the values of the subject for variables normally are distributed. The next thing I will be discussing is the measures of central tendency, which is statistics conducted to describe variables. These are referred to as the midpoint in the data or as the average of the data. These measures are the most concise statement of the nature of the data in a study. To break them through, they go as mean, mode, and median. The mean is the most commonly conducted measure of central tendency. It is the sum of the scores divided by the number of scores being summed. Next is the mode. The mode is the numerical value or the score that occurs with the greatest frequency. It does not necessarily indicate the center of the data set. And lastly, the median is the midpoint or the score that at the exact center of the ungrouped frequency distribution, the 50th percentile.
The chi-square test of independence determines whether two variables are independent or related. The test can be used with nominal or ordinal data. The procedure examines the frequencies of observed values and compares them with the frequencies that would be expected if the data categories were independent of each other. The procedure is not very powerful, thus the risk of type 2 error is high, which occurs when researchers reject the null hypothesis when it is true. Results indicate a significant difference when there is not. Excuse me, that was type 1 error. Type 2 error is when the researcher regards the null hypothesis as true, but it is false. The results indicate no significant difference when there is no difference. Pearson product moment correlation tests for the presence of a relationship between two variables, but it does not determine the cause and effect. It is also an inferential analysis technique conducted to examine bivariate correlations in studies. The result of the Pearson correlation analysis is a correlation coefficient with a value between -1 and +1. In a negative relationship, a high score on one variable is correlated with a low score on the other variable. A value of r equals +1 indicates a perfect positive relationship. In a positive relationship, a high score on one variable is correlated with a high score on the other variable. A positive correlation also exists when a low score on one variable is correlated with a low score on another variable. Variables vary or change in the same direction, either increasing or decreasing together. As the negative or positive relationships of R approach 0, the strength of the relationship decreases. For example, a positive relationship could be that when a person is taller in height, their weight tends to increase. In a negative relationship, when a chicken grows older, they have a decreased production of eggs. One of the most common analyses conducted to test for significant differences between two samples is the t-test. The t-test is used to examine group differences when the variables are measured at the interval or ratio levels. A variety of t-tests have been developed for various types of samples. For example, when independent groups are being compared, the t-test for independent samples is conducted. For paired or dependent groups, the t-test for paired samples is conducted. Sometimes researchers misuse the t-test by conducting multiple t-tests to examine differences in various aspects of data collected in a study. This misapplication results in an escalation of significance that increases the risk of type 1 error, saying that something is significant when it is not. The Bonferroni procedure, which controls for the escalation of significance, may be used when multiple t-tests must be performed on different aspects of the same dataset. This procedure makes the significance level more stringent based on the number of comparisons conducted. For example, if 5 t-tests were conducted, the level of significance would need to be set at 0.01. This is done by 0.05 divided by 5 equaling 0.01.
Analysis of variance, also known as ANOVA, is a parametric statistical technique conducted to examine difference among 3 or more groups. The variables must be measured at the interval or ratio level. There are many types of ANOVA. Rather than focusing just on difference between means, ANOVA tests for difference in variance. These variances are within group variance, between group variance, and total variance. To start, 2 groups equals significant difference clear, and 3 or more groups equals not possible to determine location of difference.
The next topic we will discuss is regression. This allows us to predict the value of one variable when the other variable or variables are known. Dependent, interval, or ratio, or outcome variable. The goal is to explain as much of the variance in the dependent variable. One independent variable predicting dependent variable equals simple linear regression. 2 or more independent variables, multiple regression. The reference we used was our Understanding Nursing Research Building an Evidence-Based Practice textbook in order to help complete this assignment.